Hello everyone, this is the week 6 lecture for the Revit course, and today I'm coming to you from my basement instead of my office, so I'm giving this a try and we'll see how the audio quality works out. Hopefully it's okay. So situation a little bit different, information will be just as good as always, I hope. So this week what I want to talk about is I want to talk about some terms and some ideas that we've kind of covered in class as we've gone through the course so far. But I just want to make sure that these ideas are kind of more clear in your head and that you're kind of understanding them and kind of what the ramifications are of them. So what I want to talk about is the idea that Revit is a tool that is a domain-specific tool. And when I say domain-specific, I'm talking about the domain of architecture. So in essence, Revit is a 3D modeler, right? But it's all the tools in it are specifically tailored towards the building industry. So, we have tools like walls and doors and windows and roofs and floors and ceilings, those kind of things. So we have really specific tools to do specific things. But in essence, really, a floor and a ceiling and a roof are all kind of the same kinds of objects. They're kind of slabs of stuff that we put in space. So it could easily, in a generic kind of modeler, it might be just called an extrusion, and you would draw the shape and you would extrude it. A roof is a little bit different and has slanted faces, but maybe you would do an extrusion and cut some pieces off of it. But anyhow, we have specific tools that are used for the modeling within Revit. So you have this collection of tools, and then, when you add in the other disciplines such as structure or systems, again, we have really, really specific tools for making specific kinds of things. I mean, honestly, a duct and a pipe and maybe a cable tray or a conduit, they're all kind of the same thing, right? I mean, if you ask most people, a lot of people might not even be able to tell you the difference in the real world between a conduit and a pipe. But to Revit, they're very different kinds of things. So that's what we're talking about when we're talking about domain-specific tools. So why necessarily do you care whether it's a domain-specific modeler or not? Well, the reason why it's important, or the reason why Revit does it, is because when we have these domain-specific tools, we can create these rules about how the tools interact with one another. So I've talked about that before, and we've seen that behavior, right? So if we have a thing called a wall, so we have a wall here, and we have a thing called a door. When we place a door, it won't place until I get near a wall, right? And then once I put it into the wall, it will go in. I happen to put it up on the second floor there. Guess I'm working on level 2. That's okay. So, but you get the idea that I have to have a wall in order for that to work. So there's rules about where a wall can go. Or likewise, if I put in a roof, say, and I will connect it up to the roof level here, and I'll use the walls, and we'll define slope all the way around. That's fine. I'll give it an overhang, maybe of 1 foot. So again, I'm using some domain kind of things. So I'm inputting it by using pick walls, and I'm giving it something called an overhang, which that only means something to somebody working in a building industry, or makes sense more there. Or I'm using this check mark define slope, right? So define slope, when I click on it, you see these little bird's mouth items that appear on the end. So this little triangle is letting me know that I have a sloped face here, and it also is giving me 9 to 12. So it lets me know what the actual slope of that thing is going to be. So these things mean something to people who know about architecture. So looking at this roof, I'm going to end up with a hip roof because every edge is going to slope up, right? And if I wanted it to be a gable roof, for example, I would do something like this. I would take these 2 ends and I would say, those I don't want to define a slope, and now that little symbol goes away. I still have a symbol here and I still have a symbol down here, so it's going to slope up in the middle, but so we now have a gable running through the middle instead of hipped ends. So if I finish this up, it adds the gable. You can see the gable got added here. And it also asks me this question about, do I want the highlighted walls to attach to the roof? Well, I can see that they're sticking up through the roof, so it makes sense that I would want them to attach. So I'll go ahead and say yes. And when I do that, so now I have this gable. Make the crop box visible here so we can see it a little better. And so you get the idea about what domain-specific tools are, is that I have this set of tools that mean something to an architect or a person who's working in the building industry. So this tool is really has all those tools. So why do we care? Why is that important? Well, we have the rules, and it also does something else. So some of the other things that it can help with is that it saves you a bunch of time and energy, right? Because I don't have to tell Revit to cut that hole, or I don't have to figure out how to slope that roof. All of that kind of intelligence is built into the object itself, so I don't have to spend time kind of managing that. There's already some tools to kind of do that. Or if I don't like, say, that end condition, there might be a tool to kind of fix that up and make it look more like the way that I want in common kind of conditions for architects. So you can save a bunch of time and effort and get things done easier, right? And it does kind of enforce good practice as well. So if I say put in windows in this end down here, I'll put a couple in. I don't really have to think about it. The item is already kind of pre-set up for me to put a sill height in at the right spot. So it lines up the head of the windows. You know, there is a sill height here to move it up and down, but it has a default value that kind of makes sense. So for these kind of really common types of items or these common conditions, the defaults get you set up and allow you to put things in without a lot of effort. So if you need something different, it's possible to do something different. It's just that the defaults make it set up really easy for you to do. So it kind of enforces kind of good practices, and because these items work in a specific way that are related to the way buildings really go together, it also forces you to design in a good way. So if I did something like this, so if I say changed the end of that, so I want to change the way that ends. That's not the way I want my thing to look. I'm going to change it from being a plumb cut to a two-cut square, we'll say, and immediately does something strange, and it looks strange to me, right? So that's not the way roofs really are, but now it's made some more parameters come alive here, so I can say, oh, well, I need a 6-inch fascia on that or whatever. So it builds that condition similar to the way it would be built in real life, right? So now I don't have to necessarily figure all of that out. So it's kind of enforced some of these good habits or the way things are actually done in the field. All right? So it does these good things, but there are also obviously some bad things that are going to happen, some stuff that you lose because of this. So you lose kind of your ability to do kind of just general things, or it's not totally gone, but you have to use different tools to get there. So you lose the ability to have just, if I want discrete control over, if I just want to change that chevron, or I want to change the swing of this arc line to just a straight line, I don't have that kind of low-level control, so I lose some of that ability to just do what I want to do. So I don't have these general tools that allow me to do whatever I want. So that can be one of those things that is kind of costly as well. And so maybe something else that you lose in addition to that, or I guess to go on with generality, if I wanted to use Revit to, say, design, say, my mouse here, right? If I was an industrial designer, I wanted to design this mouse. Could Revit design this mouse? Could it do the 3D model for this mouse? Probably, but it's not going to have really good tools for doing that, because it has good tools for building buildings, which are not this small, aren't usually this curvy. So the tools that Revit gives you to make a shape like this are a lot harder to do because you don't have those general tools. You have tools like walls and doors and windows, so you have to figure out some way to kind of get that shape out of it. So I guess that goes with the loss of generality. So if you need a tool to do those kind of things, Revit isn't going to be able to accommodate you. So if you need to do something else, it might not be the best choice. So if you spend a lot of time learning Revit and then all of a sudden need to design something else, you don't have a tool to do that, or you don't even have the skills because you've worked with these really domain-specific tools. Some of the other things another thing that is worth mentioning as well is if you have an exception to a rule, if you don't have if the end of your roof isn't going to look like that, or it's not going to look like, let's do another one, or it's not going to look like that, that's what we started with, or it's not going to look like this. Those are the three ways that you can end an edge. That's not how they end roofs in, say, Japan. A lot of the roofs have, the turned up corners. I'm sure you all have seen that. That condition is harder to do in Revit because you don't have a standard edge condition that does that. This is clearly made for kind of Western architecture, and so that kind of roof condition isn't accommodated for. Can it be made? Of course it can be made, but you have those exceptions that you're going to come across, and especially if you're flexing your muscles as a designer or if you're working in school, a lot of times you want to do those exceptions because when you get out in the real world, you have to do the kind of standard stuff. So while you're in school, it's good to do the kind of non-standard stuff. So sometimes Revit makes that a bit challenging, finding ways to do the exceptions. So that's something else that you lose when you have these kinds of tools. Another thing that makes it more difficult, especially for students, is there's a lot more to learn as you go through things. So when you're working with Revit or when you're learning Revit, you're having to learn, of course, the tools of the software itself, but because the tools are really, really tailored to certain ways of building things or the way buildings go together, there's additional things that you kind of have to know as a student about putting buildings together that you might not otherwise, if you were just using a AutoCAD, you'd never have to know. So my example here is, this is obviously like a wood-framed house. If I zoom in, you can kind of see it's 2 layers of wall, etc. And here's my section going through it, right? And in a wood-framed house, let me get rid of this door so it's not confusing us. This is really kind of the way it works, right? So you frame, the frame goes in here, and there would be a plate sitting here. So let me draw that in just so people can kind of understand what I'm talking about. So there would be some kind of plate that sits down here. Your stud, right, sits like that. And then there would be another one up here that would start the next wall. And put some lines through the middle there. So, these are like the studs. These are the plates that start the wall, or in this case, finish the wall. So that's kind of how this particular, didn't get that exactly right, but that's how that condition would be done, is you have a stud wall that goes up and it stops, and then a platform is built on top of that, and then another stud is put and it stops. So building this in a certain way. So if I select this floor and I edit the boundary of it, let's see, that will work. Isn't that what I have open already? Yeah. So you can see where the boundary line of the floor goes to. It doesn't go to the inside face of the wall. It goes all the way out to the exterior sheathing. So then that floor kind of cuts out a piece of that wall to make that look the way it's supposed to look when it's finished. So as the student learning how to use Revit, you have to understand that that's the way you would frame that condition, or that's the way you build that condition. And so the tool that you use, the boundary, has to be drawn in the right spot or your model won't look right. And as a contrast to that, if we look at this model over here, we actually have, it's done a little bit differently. In the floor is done as one element. The set of bar joists or beams here are done as a beam system. So that is the plan that I want to look at. So the beam system, in this case, the beam system, which is the trusses here, go into the wall a certain distance. They don't go all the way out to the face of the core like it did over here. It goes part of the way into the core because that's how they do it. They build like little pockets for these joists to sit into and rest. So it's actually, to do this floor, it's two elements. I have a beam system and I have a floor, and I have to know where the beam system has to end in the middle of the wall. So it's ending in the middle of the wall. And of course, at the ends, it doesn't go into the wall at all, right? Because you don't have the joist going in. So this boundary actually is kind of a little bit funny because it's not even symmetrical. It's symmetrical in the two different ways, but not all the way around. I don't have this pulled in like that, right? It's just to the face of the wall. So there's another thing where you kind of have to understand how they would build this to make it look right. And if I go to the floor and edit its boundary, you can see that it is finished up to the actual finished face of the wall. So that's the way that one would work. Actually, it might go into the face of the core. But anyhow, you get the idea that, I have to understand how that floor is actually going to be made and put together before I can start modeling it to be accurate within my Revit model. So, this is fairly accurate, that there's a floor and then there's a set of beams underneath, and I have to know how that would work, where this is a floor and it goes into and out to the sheathing face of the wall. So there's two different, it's still walls and floors, but I need to know a little bit more about the actual construction method in order for me to model it correctly. So this poses a problem as a student because you have to kind of learn a lot more, right? You're learning a bunch of tools. There's lots of different tools for every single item, as well as having to understand tectonically how buildings really go together in real life, which is going to help you model them correctly in Revit. Because if you don't understand how they go together, then the modeling becomes challenging because you don't know how to approach it and what tools to use and that kind of thing. So that can be kind of a challenge. And of course, this is still one of those things. It's also, if you have some special condition that you need to accommodate, then it's even more challenging because understanding how those special conditions go together, crazy curtain walls for, kind of biomorphic shaped buildings, a round shell or whatever. That's even a lot harder to put together than just a stick building like this. So those kind of unorthodox things can really become a challenge for students because they're even challenging in real life on how they go together. And then the last thing that I'll mention as I'm wrapping up is, like I said, it's a pretty short lesson here. There's not really even that much to show, is that because Revit has these rules and it makes putting together things like a square box with a gable roof on it very easy to do, it's deceptive and maybe a bit unfair to the student in that it kind of enforces or reinforces or drives you down a certain road with your design where you're going to want to, well, it's just easier to do this in Revit. It's just easier to draw boxes in Revit. So my design is just going to be boxes because I don't want to, I don't want to have to figure out how to do it in Revit, so I'm just going to draw these boxes. So you don't want to let the tool itself kind of limit your creativity, especially while you're in school, because take it from me, you'll have plenty of time to draw boxes and really boring stuff. In school's the time to do the really crazy stuff. So if you can't get it done, you can't figure out how to get it done, I can try to help you get some of it done, but sometimes it may be really hard for me as well, and there may be another tool that's better suited for it. So, don't feel bad, don't feel tied to Revit just because you're taking the class. There are other tools out there that you can use to get your design ideas across and communicate what you want to communicate and do your best expression and your best design. So don't let Revit's tools be confining in allowing you to express yourself with your work. So I think that's it that I have for week 6. Like I said, it's pretty short. We'll go over some more ideas related to this kind of thing when we meet in class about this on this topic. So we'll leave it at that. We'll close it down. Hopefully the sound comes out okay on this, and you enjoyed the backdrop of my basement, and we will see you next time. Thanks.